solve the log of x plus 3 equals 1 minus the log of x minus 2. Well, when we have an expression or an equation involving logarithms, we can first try to combine the logarithms on each side of the equation into just one log. And we'll do that here. Let's get all the logarithms on one side of the equation. That would be log of x plus 3 plus the log of x minus 2 equals 1. And if we add two logs, then by the property that the log of a product is the sum of the logs, I'll write that up on in the margin. There it is. By that property, we can rewrite the left-hand side as the log of the product of x plus 3 and x minus 2, and that should equal 1. Well, the log without an explicitly written base is a log base 10, and so writing this in exponential form, we see that x plus 3 times x minus 2 must just equal 10 to the first power, or simply 10. You can see that, if you like, by raising both sides with a base of 10 and treating the two sides of the equation as exponents. And then 10 to the logarithm cancels out, leaving just the x plus 3x minus 2. Well, to solve this quadratic that's equal to 10, we need to get everything onto one side and set the equation equal to 0, effectively. I'll multiply out the left-hand side, giving an x squared plus, let's see, plus 3x minus 2x is plus x, and then minus 6. When I subtract 10, that will become a minus 16, and I'll have 0 on the right-hand side. Let's see if we can refactor. Are there any factors of negative 16 that add to 8? I don't believe so. The options are negative 16 and 1, which will make a negative 15, or vice versa. We could get a positive 15 if we flip the signs. We have 8 and negative 2, which will make a plus 6. We could do 4 and negative 4, which would make no middle term. We're not going to be able to factor this, so we'll use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Here, filling in the value of b equals 1, we would see we have negative 1 plus or minus the square root of 1 squared minus 4 times a, that's also 1, times negative 16, all over 2 times a is 1, so I'll leave that as just 2. And we'll simplify. This is negative 1 plus or minus the square root of, let's see, 1 plus 64, that's 65, all over 2. So we have two values here, and we should double check that they both satisfy the original equation. We're really checking for extraneous solutions, which often appear when we solve logarithm problems. Notice that if we have x minus 2 and x is negative, we're going to have a negative value inside the logarithm. And we can get a negative here. The value of x that corresponds to the minus of the plus and minus gives us a negative value. Negative 1 minus square root of 65 over 2 is less than 0. That will be inadmissible in this term. So that value of x is not in the domain of the log of x minus 2, and therefore is not admissible. The value of x equal negative 1 plus the square root of 65 over 2 is approximately, well, let's see, the square root of 65, that's approximately 8. The square root of 64 would be 8. And so if we do negative 1 plus 8 over 2, we would have a positive number. So that root is okay. We'll have a positive number, and that won't cause any problems with the other logs. So that is the answer, the solution to the logarithmic equation.